Hi everybody, here's a question from the practice test number 15, one of the tougher ones. So I'll go through it nice and slow and hopefully you can follow along. It's a distance, speed, time problem, and it's broken up into two legs, so a journey there and a journey back. So let's go ahead and do a little diagram and set this problem up. Okay, so first of all, Chris walks at 8 kilometers an hour and runs at 12 kilometers an hour. So obviously he runs faster than he walks. One day he walks and runs on the way from his house to the library. So let's go ahead and do a diagram there. So there's his house, and then he goes to the library. So we can go house to the library, and it takes him 20. So it takes him 20 minutes. Now, I can see a problem here right away that, because your distance is in hours and your total time here is in minutes. So you want to be consistent. So let's go ahead and convert this 20 minutes into hours, and that's going to be 1/3 hours. And I got that by doing 20 divided by 60. Okay. And again, part of this journey is walking, and a part of it is running. So you have you have two trips here, or two times and two distances. You have a running part, and we can go ahead and put that. We can put run, and then we can put walk. And I'm not really sure how long each one is, but that's okay for now. Okay, on his way back from the library, he walks and runs again, but he runs twice as far as he did on the way to the library. So let's go ahead and do a diagram for that. So on the way back, he goes from the library, he goes back towards his house, and that journey, is 17.5 minutes. And again, 17.5 minutes, 17.5 divided by 60. If you do that on your calculator, you're going to get t equals 7/24 hours. Okay, so now this other piece of information here that's critical is that he runs twice as far as he did on the way back to the library. So if he ran this much on the way there, on the way back he maybe he ran this far and walked that much. So he ran twice as much. That's going to come into play a little later. Okay, let's go ahead and start setting up our equations here. The only thing that's consistent with these two routes there and back is the distance. That's the only thing. That's the only thing that's consistent. So let's go ahead and put we can put a distance here, and that is that distance again is made up of the walking distance, and let's go ahead and put that into as a small d, and we can put a little dw plus actually let me go ahead and do d run. So that's made up of the distance that's spent on running plus the distance that's spent on walking, and I'm going to go ahead and do the same thing in green here. The total distance here is again the distance that he ran plus the distance that he walked. Now you have to keep in mind that these aren't the same. The green is on the way back and the red is on the way there, so they're actually different portions here. The only thing that is the same though is the big D's. So this D is the same as this D. That's the total distance. Okay, so based on this, we can go ahead and start filling out some equations. So let's go to the red part. The red part's on the way there. So the distance run, again, that's distance equals speed times time. So distance run is what do we have here? So so the speed is 12 kilometers an hour. Okay, so that's distance here. So I'm doing dr now. That's 12 kilometers an hour times time. Okay, and time, I don't know it, so I'm just going to call that t1, and that'll be here. So that's 12 times t1. That's the distance spent on on the running part. Okay, on the walking part, it's going to be, well, he walks at 8 kilometers an hour times times the time that he takes to walk, and that's going to be it's going to be 1/3 minus t1. Okay, because if it takes him t1 minutes or hours, I should say, to walk to run this part, it'll take him the rest of the time to walk it, and the total time is 1/3 of an hour. So let's go ahead and put that here. So that's 8 times 1/3 t1. Okay, so that's the distance, and again, that is the big distance, from the house to the library. But that's on the way there. Okay, let's go ahead and I'll get my green color on here, and we'll do the same thing for the way back. Okay, for the way back, again, it's distance equals, part of the distance is running, and part of the distance is walking. So let's go ahead and set that up. We'll call it again, same thing. It'll be 12 times, but now it's going to be t2 because it's a different amount of time running. Plus, and then it's going to be 8, and again, very similar. So there should have been a minus sign in here. Very similar to the above one, except the walking time is a little bit, or the total time is a little bit shorter. It's 17 over 24. 17 or 7 over 24. 24 minus t2. Okay. So again, the key thing here is that the total time is 7 over 24 hours. And if he runs a t2 time, then the rest of the time is spent walking, which is 7 over 24 minus t2. Okay, now the only problem here is that we have t1 and we have t2. So somehow we have to convert this t2 to look like to be in terms of t1. And where you can get that information from is this little sentence here that says that he runs twice as far as he did on the way to the library. So if he ran this distance here, he ran twice as far on the way back. Okay, so let's go ahead and use that information to come up with a little side equation that's going to help us out here. Well, here it is. Okay, if he ran, or if the total distance he ran is d, and I'll put here dr for distance ran. This is for this first part on the way to the library, is 12 t1, and the question tells us that he ran twice as far on the way back. Okay, well, that would mean that that 2dr, okay, that 2dr would equal 2 times dr would equal how much he ran on the way back, and how much he ran on the way back is 12 t2. 12 t2. So again, let me go ahead and sort of, we're getting a lot of variables here that are kind of overlapping a little bit. We just want to make sure that you're clear on which variable is which. Again, this is the distance. This is the distance ran on the way there, and that was 12 t1. Okay, right here. On the way back, he ran 12 t2, but we know that that he ran twice as much on the way back. So if I multiply, if I double the first distance on the way there, it should equal the second distance on the way back, and that's exactly what I'm doing down here. I'm doubling dr, and that's going to equal the running on the return leg. But again, dr is just 12 t1, so it's going to be 2 times 12 t1 equals 12 t2. Okay, and now that's going to be 24 t1 equals 12 t2. And what I'm going to do now is I'm going to solve for t2 and then substitute that into my second equation, the green equation. So 24, divide both sides by 12, and I get 2t1 equals t2. So now that I have t2, I'm going to go ahead and put that into here and into here. And I'm going to rewrite my green equation to be 12 2t1 plus 8, and then 7 over 24 minus 2t1. Okay, and now I have two equations that are all in terms of t1. And again, the key thing to this whole problem is that this distance equals this distance, so I can equate those two equations to equal each other. In other words, the red part equals the green part because the distance is the same. So let's go ahead and do that on the fresh line here. It's going to be 12 t1 plus, and I'm just going to go ahead and distribute this right now, 8 over 3 minus 8 t1. That's going to equal the green part, which is going to be, and again, I'm going to go ahead and do some distributions here. So that's going to be 24 t1. That's going to cancel into a 3 plus 7 over 3 minus 16 t1. Okay, and now I have everything in terms of t1, and I can go ahead and solve this equation. So let me go ahead and start simplifying some stuff. I have 12 t1 minus, that's going to be 4 t1 here, so that's 4 t1, 8 over 3 plus 4 t1. Let me cross that out. 24 minus 16 is going to be 8 t1 on this side, 8 t1 plus 7 over 3. Now let me move the 4 over here and this over there. So it's going to be 8/3 minus 7/3. It's going to be 1/3 equals 4 t1. And finally, t1 equals 1 over 12. Okay, so finally we've calculated one of these variables, and the time 1 equals 1 over 12, and that's hours. The question says, what is the distance between the house and the library? So that we can use this now to find that distance. Well, t1 remember is this part over here. So the distance for the running part, we can go ahead and just multiply 12 times 1 over 12, and that's going to be the distance of running. So that's going to be 1 kilometer. Okay, so that is 1 kilometer. Let me label that on the diagram. So that's 1 kilometer there. Now the walking part is going to be 8 times 1/3 minus t1, which is 1 over 12. Let me go ahead and make sure I got that correct. Yeah, 1/3. There's the second equation. So that's the distance of the second part, the walking part, and that is going to be, let me go ahead and simplify this first of all. So that's times both by 4, that's 4 over 12. And it's going to be 8 times 3 over 12, which is going to be 8, which is going to equal to 2 kilometers. Once I simplify that, so that's the walking part. That's the walking part, 2 kilometers. So the total distance is 3 kilometers, and there's your answer there. Okay, so a little bit. This one is probably one of the toughest questions. You're probably not going to get one as tough on the test, but it's good to know it because next year you're probably going to come across some of these tougher questions. Okay, thanks for watching.